Hi, I'm Locady, and I wanted to describe how at least some of the pattern matching works. I'm going to use these color images of somewhat random products and talk about what what's happening in the pattern matching. Now, in this case, I am using LabVIEW, and I'm going to be using the feature detector called FAST. In that case, in the FAST feature detector, it goes through the entire image and it looks for every single pixel that's 3 pixels away from that pixel. It compares the intensity of the sampled pixel to the pixel 3 pixels away. Kind of complicated. There's a ring around every single pixel, and it looks at the brightness difference between the point in the center of that ring and the ring. If the value, the difference in value, is greater than the threshold, and if the points, the pixels, are continuous above a fixed number, maybe that number is 10 pixels, maybe it's 8. Honestly, I don't know what it is for this particular FAST algorithm. In some instances, you can change how many continuous points there are. But if the criteria is met, if the contrast is high, if there are continuous points of high contrast, then that pixel is considered as a feature in the image. The features are used in order to identify the there's a feature matching algorithm, and each pattern match tool might be a little bit different, but ultimately you have a model of points, features, and you have an image with a whole bunch of samples. And the algorithms will look for which points line up, and it will find the homography matrix that allows the template set of features to be identified in the new image. But what is a good place to have a pattern template? On this image, I have the current feature point settings set so high it could find no features. So I'm going to drop this down to a more reasonable 64, so step of 64, and we'll run that again. And now we can see a whole bunch of little dots. Now this is a color image. The FAST algorithm only works on grayscale, so what I did is I broke the color image up into red, green, and blue channels, and so each of these little dots on the screen represent whether it was a feature in red, the red channel, or the green channel, or the blue channel. But what you want to see for pattern matching is a good distribution in 2 dimensions of the features. So you don't want them all in a straight line, because anything on a line could be anywhere on that line. You want to have a match in 2 different axes. So in this case, the image, whatever this was, because it's covered up now, I don't know what it was, this would actually be a good feature to make a template out of over here on the right, because there's a 2-dimensional shape there. Actually, a portion of the text would be good, but probably not all the text. A combination of the text up here at the top right corner, as well as the block, the circle underneath. That would be a pretty good pattern to select, because they're unique. They have asymmetrical, well, this one's symmetrical, at least left-right symmetrical, but it's asymmetrical in the y-axis. So that would be a good option. And then the other thing is, do you know if you've got too many features or not? Unfortunately, with a lot of the algorithms, there's no way to know, and that's why I created this, just so I could see what are the features that exist in this image if my feature limit is 64. And I'm going to just step through a bunch of images and we'll see, well, there's some noise in the background. That's an interesting one because I would have not guessed that this little coconut shape was actually a good feature to pattern match on. I knew that the circle with the Nivea text in it was good, but I also thought the circle was actually good, but apparently it's not as good as some of the other objects in here. Okay, this one is a mess, honestly. All of this text is linear and there's a lot of features there, but they're repetitive. So a better location for features would be actually over in this image of the whatever the heck vegetables those are. Spinach. I don't eat spinach. So yeah, spinach. The spinach would be a good choice there. Spinach is never a good choice unless you're talking about this. Okay. Okay, so this one, it looks like some of the text, some of the logo. Although in this case, it's really interesting that there's no features on most of this package. And in order to get a two-dimensional pattern, you'd actually need a large pattern to sample. Let's look at another one. That's actually a different scale. I don't know, look at that one right now. There's another better, smaller example of that. Okay, this one, unfortunately, it looks like everything is linear. So perhaps including the points here at the edge of the box, the entire thing might actually be the best pattern. Now, this is interesting. So here is a case where the text has a whole bunch of features, but if you were to include this text with this circle, that's actually a nice little template that gives information in two dimensions. Between the circle and the text, there's some X information, and the text itself has a lot of Y information. So that's not bad. Okay, this one, it's kind of a mess, and at first you might think, oh, I'm going to go after the words. But if you look over at the seeds, the bird seed, I guess is what this is, a bird seed snack, I have no idea. There are red and green and blue features over there, and there's quite a few of them. So this actually might be a better location to do a pattern match just because of all the features that exist over there. Is that the last one? Yep, that was the last one. Okay, so that is a feature setting that I basically put at 64, which is a quarter of the image has changed, right? The full range of an image is 0 to 255. 64 is 25% of that. So I'm basically saying anything's a feature if at least 25% of the brightness has changed around that pixel. What if we said it was less? What if we said 32? My guess is we're going to get a lot of noise. Yeah. Okay, so everything got denser. We started picking up stuff around the outside edges. I guess that's not super significant. This is actually not terrible. Let's step through them all again just as a comparison. Okay, that one's a mess, but it's there. Whoa is all I got to say about that. That just looks like a cactus now, which I guess if you really wanted to use for eating, it's perfectly as good as, I don't know, spinach. This did not help the empty space of that, so all it did was increase the density on the stuff we already had. Skip that one. Didn't really help a whole lot here. The corners kind of stood out a little bit more, maybe. About the same. Actually, I would say there's more noise on that. And look at that. Over there on that birdseed bar, there is a really good, even more red, green, and blue sample. So that actually makes me think that might be a better spot to go for. And we're back to our first one. So what happens if you're going the wrong direction? So we were at 64. What if we were at 128? So we're going the other way. We're saying that we only want the samples that have a high, very high change in brightness. And what does that look like? We're going to get a lot fewer samples. So in this case, we lost our little shield information. We got some text here and some text here, and that's about it. Only the text and a few points around that little coconut. Nothing. I mean, there's pretty much nothing here. There's something here, there's a couple of spots here, but this one, not a lot of options there. That's interesting. I don't know what to say about that. That's why it's interesting. This one, there are only a couple of points right here in the text. And again, it's all linear, and we're skipping that one. And this lost its corner points, and now we only have points in a line. That one's actually still okay. We have points along that circle and points along the text, so there's still 2 dimensions. It's good. I'm not saying loser, I'm saying 2 dimension. We lost all of our detail on the birdseed bar, and we only have text. This gluten-free shows up. That's okay. But look at the bottom down here. This is all like linear, and so the pattern would end up shifting along that. Put that one down. The pattern would end up shifting along that text because there's a whole bunch of features that it could match to. What else? Oh, we're back to the beginning. All right, so how can you tell on any given vision system and any algorithm? You can't. All I'm trying to show is this is one way, this is a very common way that pattern features are identified. This is a common algorithm that many pattern matching algorithms use. So I just wanted to illustrate sometimes what you think is a good pattern might not be to the algorithm, because what's happening behind the scenes isn't easily detectable by humans. But the one takeaway is you do want something that has 2 dimensions of features. You don't want a single line in any axis. You want 2 dimensions. And that's all I got.